Optimization of different anti-stripping agents in construction of flexible pavement. Abstract. The aim of this research project is to improve current practice by investigating different test methods to quantify moisture damage to serve the short and long-term needs of the agency and industry. This research deals with important concepts of stripping as bitumen chemistry and rheology, aggregate properties, chemical and mineralogical composition, surface texture, morphology, porosity, etc., traffic, water properties, construction practices, mixing, placement and in-service drainage, and nature of anti-stripping additives. This paper presents the effect of anti-stripping additives in bituminous mixes. As per research, a series of laboratory tests have been conducted with varying percentage of these anti-stripping additives, added individually and in combinations, to determine their optimum percentages. This report presents the results of experimental investigations carried out to study the effect of Wetbond-S, Zycotherm, and Bitugrip on bitumen and aggregate. Boiling water test and stripping value test were conducted as screening tests performed on Wetbond-S, Bitugrip, and Zycotherm modified bitumen. The current research shows the optimization of different anti-stripping additives to evaluate moisture susceptibilities of bituminous mixes. This paper deals with the review of some previous studies that are done to improve the adhesion between bitumen and aggregate. The stripping value decreases while increasing the percentage of anti-stripping additives to the bitumen. The results indicated that the addition of anti-stripping agents increased moisture resistance of asphalt mixes to some extent. Moreover, it was concluded that mixed samples prepared using anti-stripping additive imparted more correlation and greater resistance to water damage. Keywords: bitumen, aggregate, adhesion, stripping, Wetbond-S, Zycotherm, Bitugrip, boiling water test, stripping value test. 1. Introduction. Road sectors are the engines of growth for economy, employment, and empowerment. Owing to increases in household income, the demands for personalized vehicles have also increased. In India, 95% of roads are bituminous roads, which consists approximately 93 to 95% of aggregate and 5 to 7% of binder material. Until now, conventional bituminous binders were performing satisfactory results, but with increase in traffic intensity there is a need of better binder material which can perform better under heavy traffic loads without compromising the performance of bituminous mix. Many mileages of roadway worldwide have been replaced prematurely, due to moisture-induced damage in form of stripping. During rainy season, the natural bitumen become failure and possess serious problem. Due to the movement of vehicular traffic, treatment and strengthening of bitumen appear to be the only solution for keeping the pavement of surfaces serviceable. Loss of adhesion also renders cohesive resistance of the interstitial bitumen useless. In recent years, stripping has been a serious problem in asphalt paving mixture. The loss of bond between aggregates and asphalt binder that generally begins at the bottom of the HMA layer and progresses upward is understood to be stripping of pavement. It causes functional weakening of pavements leading to costly repairs. It can also cause the premature pavement failures like rutting and raveling on the pavement surface. The most common technique to mitigate moisture damage is the use of additives or modifiers with the asphalt binder or the aggregate. To alleviate or to regulate the deformations due to water damage, various researches were performed resulting in the use of anti-stripping additives. Anti-stripping additives are used to increase physiochemical bond between the bitumen and aggregate and to improve wetting by lowering the surface tension of the bitumen. Numerous studies indicate that anti-stripping additives can positively affect the binder-aggregate bonding characteristics and overall mixture performance by reducing mixture's moisture susceptibility. In India, method of determination of stripping value of road aggregates is 6241-1971, is the standard describing the stripping test for the coarse aggregates. The research is done by adding the anti-stripping agents to the bitumen. The stripping value test is performed to describe the property of the anti-stripping agents on the bitumen. 1.1 Adhesion. One of the fundamental properties for good performances of bituminous pavement is proper adhesion between aggregate and bitumen. The adhesion between mineral aggregates and bitumen is an important criterion which describes the quality of asphalt mixture, asphalt performance, and resistance to distress. The lack of bonding can lead to significant asphalt pavement damage. For the evaluation of the adhesion behavior between bitumen and aggregates, used in road construction, many tests have been practiced. The adhesion is influenced by the characteristics of both the bitumen and the aggregate used in the mixture. Adhesion can be generally defined as the molecular force of attraction between two bodies of different nature in contact with each other. 1.2 Stripping. The use of bitumen is reflected in many applications and dates to ancient times. In bituminous mixes, bitumen holds the aggregates, forming a mass that supports high stresses. It is crucial that strong and durable interfacial bonds exist under all conditions. Depending on how bitumen interacts with aggregate, stripping may affect this desirable precept. Stripping is the breaking of the adhesion bond between the aggregates and the bituminous binder. In one way or the other, water gets in between the binder film and the aggregate surface, and because the aggregate surface has higher attraction for water than for bituminous binder, then adhesive bond is broken. It is one of the most commonly occurring distresses in asphalt pavements. Surface moisture content is most desirable factor for stripping analysis, as most of the bond loss between aggregate and binder starts from pavement surface due to the moisture content from atmosphere and other outer sources. 2. Literature review. The following literature review describes important research results regarding use of Wetbond-S, Zycotherm, and Bitugrip in bituminous mix in construction of flexible pavement. Mahmood Ameri, Sari Kauchaki, 2013. 6. The objective of this research study was to evaluate moisture susceptibility of hot mix asphalt, HMA, with and without Zycosoil as a nano-organosilane anti-stripping additive and hydrated lime in the form of slurry. It was also observed that the effects of anti-stripping additives on specimens made by siliceous aggregate are more pronounced than those prepared with limestone aggregates. The use of Zycosoil additive will increase adhesion bond between the aggregates and asphalt binders, and in turn influences the moisture resistance of the mixture to moisture damage. Daewoo Park, Woojin Seo, 2017. 1. This paper studied that evaluation of moisture susceptibility of asphalt mixture using liquid anti-stripping agents. The purposes of this study are to comprehensively evaluate the moisture susceptibility of asphalt mixtures modified with several anti-stripping additives based on laboratory tests. Boiling water test was conducted as a screening test. The addition of anti-stripping agents significantly improves asphalt mixture stripping resistance before and after stripping occurs, and rutting resistance. Harpreet Singh, Tanajay Chopra, 2017. 4. In this study, Zycotherm additive is added to neat bitumen and various comparisons were made using conventional test and rheological test on bitumen. Zycotherm gives better chemical bonding for extended moisture resistance, and it ensures about 100% coating of bitumen at low temperature. Haim Tom Rainey, Ali Reza Ghanazadeh, 2017. 3. The primary objective of this study is exploring the moisture susceptibility of unmodified and SBS modified hot and warm mix asphalt mixtures. 2 different WMA additives including Asphalt and Susceptibility were employed to fabricate WMA specimens. The moisture susceptibility of warm polymer modified asphalt, WPMA, mixes was evaluated. In addition, the effect of different percentages of hydrated lime, from 0% to 2%, and Zycosoil, from 0% to 0.1%, as anti-stripping additives on the moisture susceptibility of the mixtures was explored. The test results showed that increasing moisture content decreases moisture damage resistance. Addition of hydrated lime improves moisture susceptibility. The results also showed that moisture sensitivity was affected significantly by the source of used aggregate. H. Kani Sanaj, P. of Kami Maybody, 2018. 2. The primary goal of these efforts is to improve the durability and load-bearing performance of asphalt mixtures. In this study, glass particles were used as aggregates in warm mix asphalt (WMA) mixtures. The objective of this study was to consequences the utilization of Zycotherm trademark as an anti-stripping agent have on the mechanical properties and moisture susceptibility of glass asphalt. 4 different amounts of Zycotherm trademark were used in WMA mixtures to serve as bitumen modifier and anti-stripping agent. In this study, glass particles were used as aggregates in warm mix asphalt (WMA) mixtures. 4 different amounts of Zycotherm TM were utilized in WMA mixtures to serve as bitumen modifier and anti-stripping agent. Kunal Kumar Vatala, ASO. Professor Vijay Chitaria, 2018. 5. This study investigates the effects of anti-stripping agent on the microscopic strength of the mineral aggregate contact surface of mixture. The study compared the moisture susceptibility of 3 variations of bituminous concrete grade 1 mix, I, mix without anti-stripping additive, 2, mix with hydrated lime as an anti-stripping additive and 3, mix with psychosoil as an anti-stripping additive. The current study resulted in improved bituminous mixtures with the utilization of anti-stripping additives, especially in the moisture resistance property of the mixture. Shazi, Professor D. S. Ray, 2018. 7. This paper aims at the study of potholes on the bituminous road surface and introducing the anti-stripping material to the bitumen to increase the durability of the road. In this paper, the anti-stripping material Bitugrip is used to improve the adhesion properties of bitumen and aggregates. The stripping value decreases while increasing the percentage of Bitugrip to the bitumen. Overall, the addition of Bitugrip has a positive influence on the adhesion properties between the aggregates and the bitumen and can be used to increase the durability of roads, thereby reduce the maintenance cost of the roads. 3. Materials. To construct a flexible pavement, basically bitumen and aggregates are used. Here 3 anti-stripping agents i.e. Wetbond-S, Zycotherm, and Bitugrip are used to mitigate the problem like stripping, rutting, rattling, potholes, cracking etc. and also to reduce maintenance cost and increase service life of pavement. The details of these materials used in this research are mentioned below. 3.1 Bitumen. Bitumen is hydrocarbon material, found in gaseous, liquid, semi-solid, or solid form and is completely soluble in carbon disulfide and in carbon tetrachloride. It contains 87% carbon, 11% hydrogen, and 2% oxygen. Bitumen is a complex organic material and occurs either naturally or may be obtained artificially during the distillation of petroleum. Bituminous materials are very commonly used in highway construction because of their binding and waterproofing properties. In this study, VG30 bitumen grade is used as a base binder. 3.2 Aggregates. Aggregates forms the major portion of pavement structure and they form the prime materials used in pavement construction. Aggregates have to bear stresses occurring due to wheel loads on the pavement and on the surface course they also have to resist wear due to abrasive action of traffic. Aggregates are inert granular materials like sand, gravel, or crushed stone. Gravel aggregates are small rounded stones of different sizes. Aggregates were used local granite rocks of such particle size obtained from Cabaret quarry situated in Mahoba that are 100% passed from a 20 mm sieve and were retained on a 13.2 mm sieve. The aggregate was washed in distilled water to get rid of all fines dried at 105 to 110. To constant weight and stored in airtight containers until required to be used. Crushed granite aggregates obtained from nearby quarry was used for the study and they were sufficiently strong, hard, tough, and well-shaped. 3.3 Zycotherm. Zycotherm additive is an odorless nano-organosilane additive used for bituminous mixes. Zycotherm gives better chemical bonding for extended moisture resistance and it ensures about 100% coating of bitumen at low temperature. In addition, this additive can reduce the production and compaction temperature of asphalt mixtures. 3.4 Bitugrip. Bitugrip is the product of Hinkle, Hindustan Coal Pvt. Limited. Hinkle Bitugrip is an amine-based anti-stripping agent that changes interfacial surface tension between bitumen and aggregate, strengthening the bond for long-run durability. 3.5 Wetbond-S. Wetbond-S is next-generation nanotechnology silicon-based ASA for asphalt. This product is a low-dose and extremely thermal-resistive additive for use in hot mix and warm mix road constructions. This product is especially suitable for aggregates having very high and difficult-to-manage stripping profile. This product is suitable for production of refinery-treated non-stripping bitumen, hot mix pavement constructions, warm mix constructions, and for industrial bituminous coatings. Advantages of anti-stripping agents. Enhance the service life of the pavement. Excellent adhesion promoter onto all type of aggregates. Slow down age hardening of bitumen. Low dosage required. Stable at high process temperature of hot mix temperature. 4 Experimental investigation. In the first, boiling water test and stripping value test were done without adding any ASA and calculate the stripping value. After that these 3 ASA were used with various percentages like Wetbond-S and 0.05, 0.07, 0.10 and 0.15%, Zycotherm and 0.05, 0.075, 0.10 and 0.15% and Bitugrip and 0.5, 0.75, 1.0 and 1.5% by weight of bitumen to check the optimum dosages of all these ASA. As Wetbond-S showed min stripping at 0.10%, Zycotherm at 0.075% and Bitugrip at 1.0%. After getting optimum dosage, combination was made to obtain minimum value of stripping. Case 1, boiling water test is performed without adding any ASA in bituminous mix. Case 2, when 0.10% Wetbond-S is added in the mix in boiling water test. Case 3, when 0.075% Zycotherm is added in mix in boiling water test. Case 4, when 1% Bitugrip is added in mix in boiling water test. Case 5, stripping value test performed without adding any ASA. Case 6, when 0.10% Wetbond-S added to the mix in stripping value test. Case 7, when 0.075% Zycotherm is added to mix in stripping value test. Case 8, when 1% Bitugrip added in mix in stripping value test. As Wetbond-S and Zycotherm had given better result compared to Bitugrip so here Bitugrip was neglected. Case 9, when Wetbond-S and Zycotherm is added in mix in boiling water test. Case 10, when Wetbond-S and Zycotherm is added in bituminous mix in stripping value test. 5 Result analysis and discussion. Maintenance cost, Rs. Anti-stripping agents, GM. Maintenance cost of optimum percentages of combination of additives. 6 Conclusion. Following conclusions are derived based on laboratory investigations keeping in mind all aspect procedures of codal practice. ASAS, Wetbond-S, Zycotherm and Bitugrip, are chemical admixtures containing active functional groups that improves the adhesion of the bitumen film on the surface of aggregate. It has been observed that after addition of Wetbond-S, Zycotherm and Bitugrip, the stripping of bituminous mix is reduced. Wetbond-S is the most effective in decreasing the stripping value of mixes in case of boiling water test, while in same way, Zycotherm is the most effective in case of stripping value test. After analyzing all the data that is collected or generated, it is found that Wetbond-S and Zycotherm is the best combination of for anti-stripping and most economical as compared to individual used. After adding combination of Wetbond-S and Zycotherm to bituminous mix, maximum saving in boiling water test and stripping value test is 86% and 82.5% RESP considering all aspect. Thus, due to the saving in maintenance cost, less quantity of material will be applicable so that huge amount of money can be saved. As these additives are silane-based additives, minimize the moisture damage as a coating of bitumen is formed around the aggregate. When are mixed with the bituminous binder, lower the surface tension of the bitumen. As the are of low cost, therefore, it is expected to reduce the life cycle cost of the bituminous pavements. Using durability of road increases as proved in the study. 7. Future scope. Based on present work and findings, it is felt that further work should be pursued in the following area. The evaluation methods consider mainly moisture sensitivity as the main factor due to which stripping occurs. Damage may occur in base course. Evaluation should be carried out considering base course damage. Further investigation should be carried out different grades of bitumen. No mechanism has been developed yet to determine stripping value. Observations are done visually. In laboratory, distilled water is used in experimentation which is neutral with pH 7, but there is a large variation in pH value of water in the field.